So, welcome back. So today I will talk about the principle of hydraulic machines, hydraulic lifts and hydraulic brakes. The principle is very simple. It's called the Pascals Law of transmission of fluid pressure. The Pascals Law of transmission of fluid pressure. Now, if you look at this simple arrangement, where there is a vessel which has a wide tube with a piston, and there are three tubes just like that, maybe of various areas of cross section or maybe of the same, it doesn't matter. Now, initially the fluid level and the liquid level is the same all over, and this is, all of them, they have the atmospheric pressure PA, okay, atmospheric pressure initially. This one is also having being at the atmospheric pressure. Now we have pushed this cylinder, cylinder is fitted over here, pushed a little bit, okay. So the liquid now rises in all of the tubes, and in the condition of equilibrium, what we find is that the liquid or fluid level all over is the same, okay, and the pressure which is exerted by this is determined by rho GH, okay. Now, so the pressure in the horizontal cylinder is indicated by the height of the liquid columns over here that are raised in the vertical tubes, which are same in all tubes. Same in all tubes. If we push the piston here further, then the fluid level rises further, but again to the same level. The pressure increase in the cylinder is distributed uniformly throughout. The pressure which you put over here, this is distributed equally in all the tubes 1, 2, 3, okay. So now the pressure is distributed and transmitted. So we say that whenever external pressure is applied in any part of the fluid contained in a vessel, it is transmitted undiminished, and equally in all directions. This is what is called, this is the statement of the Pascal's law for transmission of fluid pressure. And based on this simple Pascal's law of transmission of fluid pressure, we can have the hydraulic machines, hydraulic lift and hydraulic brakes that we'll discuss in the following. We are talking about a hydraulic lift, which is normally used in service stations, where we have two pistons, piston number 1 and piston number 2, with a raised platform, and the area of cross section of first piston is A1, the second is A2, and of course A1 is less than A2, okay. The two pistons are separated by the space filled with a fluid, a liquid, okay, and I reiterate that the area of cross section of first piston is less than the area of cross section of the second piston. Okay. What happens is that we exert a force F1 on the first cylinder, on the first piston we exert a force, and thereby we create a pressure F1 divided by A1 as per the definition of pressure. Now this force which creates the pressure that is created by the force is transmitted throughout to cylinder 2 of area of the piston being equal to A2. So what I can write is that this force which is applied in the upward direction because of the application of this force F1, this becomes equal to F2 is equal to the P multiplied by A2. This is according to the principle of Pascal's law, which I just discussed with you. So I can write that F2 is equal to PA2, and for P I substitute F1 upon A1. So this becomes F1 upon A1 into A2. Okay. Now look here. So that means A1 and A2 are the constants for the system that has been described. So actually F2 depends upon F1. Okay. And by change in the value of F1, platform 2 or where we are putting a car or a truck or anything very heavy thing, that can be raised or lowered by increasing or decreasing the force F1. Okay. So we find that the applied force is increased by a factor of A2 upon A1. A2 upon A1. Okay. This multiplies F1 and gives you the value of force F2. This is also called the mechanical advantage of this machine. So there is a very simple question through which I try to strengthen the idea that was given for the Pascal's law of distribution of and transmission of pressure. The question I read for you: two syringes of different cross sections. So syringes are tubes, one and the same. The cross sections are A1 and A2 respectively. They are filled with water and they are connected by a rubber tube tightly fitted, filled with water. Okay, so all through there is water. A schematic diagram that I have shown is that this is one syringe and this is the other syringe. Okay, and I have not shown the appropriate levels. You can find yourself if one should be lower and the other should be upper, etc. A1 is equal to pi this. That means that the radius is 0.5 centimeters and A2 is, the radius is 3 centimeters. I'm sorry, 1.5 centimeters. So that we can find out areas A1 and A2. Find force exerted on the larger piston, on this piston, this F2, if F1 is equal to 10 newtons, which can be obtained by putting a weight of 1 kilogram. 1 kilogram mass has got a weight equal to 10 newtons at the surface of the earth. And when this force F1 is applied on the smaller piston, if the smaller piston is pushed in through this much how much will the larger piston move out? So this is the body of the question. And now, as I told you, that whenever there is a big body of the question, we can always say that question in our own words. This is the first principle. So, let me solve it for you. So, what is the Pascal's law? The Pascal's law is that F1 upon A1 is equal to F2 upon A2. Always remember this equation. And from that equation I can derive F2 is equal to A2 upon A1 into F1 or any other relation between the variables. Substitute the values and I get, this is actually 3 times this value. So that means this is squared and this becomes equal to 9 times. 9-fold and 9 into 10 is equal to 90 newtons. Okay. Now for the second part, when this syringe is pushed through by 6 centimeters, 6 into 10 to the power minus 2 meters, whatever, then actually whatever push of the volume here, the volume V1 and the volume here, that will be V2. Because the total volume of the system has to be the same. The volume pushed in and the volume pushing out the second syringe, they should be equal. If so, then V1 is equal to V2. So I can say that the length multiplied by A1, that will be displaced, and length multiplied L2 into A2. So using this formula I can write, this is the basic formula. As V1 is equal to V2, therefore L1A1 is equal to L2A2. This is how we have to start. Not by a formula like this, which some of our friends, they tell you to remember these formulas. No. You have to write this formula and this formula, they are logical to remember. And one can remember them easily. Just writing that, this will be 1 upon 9. So if I divide this 0.606 by 9, I'll get about 0.0067 meters, which is 0.67 centimeters. Okay, but how should I write it? I should write it as 6.7 into 10 to the power of minus 3 meters, or 6.7 millimeters. Okay, so this is how this very simple question has been solved, and it shows us, gives us a glimpse into how the lifts, hydraulic lifts, they work, they function. So we are going to do another exercise for the case of the car lift. Okay, here in this case we are not using water or oil, but instead what we are using is compressed air. Okay, the car lift, compressed air exerts a force F1 on a small piston of radius R1 is equal to R. This pressure is transmitted to a second piston of radius R2 is equal to NR. It has to be larger, so N is greater than 1. Okay. If the mass of the car to be lifted is m kilogram, maybe it is more than 1000 of kilograms, the first thing we are asked, the task given is calculate F1 and also calculate the pressure required to lift this car. Take value of G as equal to G meters per second square. 10 or 9.8, doesn't matter. I have not taken any numerical values. The values have been taken in symbols. So first of all, this Pascal's equation, that distribution of pressure throughout is the same. So in the case of these two cylinders, F1 upon A1 must be equal to F2 upon A2. Now what we have to calculate this time? We have to calculate the value of A1. So the F1. So F1 will become equal to, A1 will come here, F1 is equal to F1, A1 upon A2 into F2. And F2 is known to us. M is the mass and G is the acceleration due to gravity. Then the force exerted by the car becomes equal to mg. And I write the area of cross section A1 is equal to pi r square and A2 is equal to pi n r whole square. So naturally pi and r square they cancel and I get here 1 upon n square. So the force that we have to exert on the cylinder of a smaller area of cross section F1 turns out to be equal to mg upon n square. If n is 4, mg upon 16. If n is 10, then it is mg upon 100. So this is how the force is calculated. Okay. Naturally, n is larger than 1, so that this value will turn out to be less than mg. Okay, that's why I have taken the numerical value, not taken the numerical values. And to calculate the pressure, I will just use one of the values, F1 divided by A1. It could be F2 divided by A2, anything we can take. So I can write this as equal to mg upon n square, which we have calculated over here, just divided pi r square. So this becomes mg upon pi r square into n square, pi n square r square. Of course, when you write the result, then always check that the value of the P is given in Pascals. Okay, the value of force is given in newtons. Okay, if it is F2 upon A2, then again, if we know the value of F2, mg divided by A2, which is equal to pi n square nr whole square. So the same result is again obtained if mg divided by pi into n square r square, the same value. Okay. And this is how we can obtain the result. So I have just tried to show you, not in terms of numerical values, but in terms of some ratios. And this is where you can be asked questions where you have one choice out of 4. What we call that multiple choice questions can be based on this kind of a relationship. Now, to wind up this part of the hydraulic machines, I have not talked to you in detail the hydraulic machine called the hydraulic brakes, which we often apply in automobiles. The brakes in automobiles, there is a cylinder which is pushed, which is connected to the shoes in the wheels, okay, and through what is known as brake oil. So the pressure is transmitted through the brake oil in the same kind of arrangement like we did see in between two syringes, same kind of arrangement. The only thing is that this is distributed over the 4 wheels of a four-wheeler or one of the wheels, whatever suits in the case of motorcycles or scooters. Okay. So with that, we come to an end of hydraulic machines. I thought that I will be able to talk about Eureka, but I'm not combining that Eureka, that is the buoyancy, with this lecture. Rather, I'll combine that Eureka with the, in the next lecture I'll take it up and then combine it with streamline flow of fluids. So, thank you very much for being with us, and I long to have your questions so that I can give you the proper answers. Thank you very much. See you again.